Hopefully you tried that problem. Let's do this together and find the solution, both graphically and algebraically. So we want to look at the average rate of change from -1 to 4 of the function absolute value of x. Let's calculate that. The average rate of change is going to be a difference in y values divided by a difference in x values. In this case, I plug in a of 4 minus a of -1 in the numerator. In the denominator, I write 4 minus -1. Absolute value of 4 is just 4. Absolute value of -1 is a +1. In the denominator, 4 minus -1 is a 5. So that means the average rate of change is 3/5. I'm going to look at this one graphically first. I have graphed the absolute value of x in purple. And then I've drawn the line segment that connects the point -1, 1 to the point 4, 4. It's pretty clear that in this situation, when the x value is below 0, the slope of absolute value is -1. When the x value is above 0, the slope of the absolute value is +1. So the instantaneous rate of change is always either -1 or +1. Now at 0, the instantaneous rate of change does not exist because we have a sharp corner. So the instantaneous rate of change is either -1 when x is less than 0, +1 when x is greater than 0, or when x is 0, the instantaneous rate of change does not exist. So you can see that we're never going to get an instantaneous rate of change of 3/5 because we're always going to have either a 1, a -1, or a does not exist. We can do that algebraically as well. The way we have to deal with this is we have to think of absolute value as a piecewise defined function algebraically, which means that the absolute value of x is defined as x when x is at or above 0, and is defined as -x when x is less than 0. If I take the derivative of this piecewise defined function, we can say, well, when x is greater than 0, the derivative of x is just 1. When x is less than 0, the derivative of -x is -1. And at 0, the derivative does not exist. I'll just write it that way. So is there ever a point that the derivative could possibly equal 3/5? No, because my derivatives can only equal 1 or -1 as real numbers. So in this case, again, the average rate of change was not equal to an instantaneous rate of change for any value of x. In other words, no value of x has instantaneous rate of change equal to the average rate of change. At least over this interval. Over other intervals, we'd be fine. I hope you can see that the problem spot here is right at the 0. Because the derivative doesn't exist at 0, that kind of throws my ideas off. So that trouble spot at 0 makes it impossible to find an x value whose instantaneous rate of change is equal to the average rate of change on the interval.